So the next data type is complex data type. This complex data type represents complex numbers 3 plus 4j. Instead of I, we use j in Python. Wow. What is j here? J is the suffix small j or capital J indicates the square root of -1. In physics, the I an imaginary number I equal to root over -1 Python dana j go. It can be represented by either small j or capital J. Natragana lowercase j or uppercase j. So Python the complex numbers will represent the VI. So we define a variable C1. C1 have a variable defined already, and then we assign the complex number 0.1 minus 2j. 0.1 minus 2j have a complex number z. C1 have a variable is the assigned already. Now, since the variable C1 contains a complex number, its type should be complex type. So let me click on this cell and let me run this cell. It should produce a complex output. So the output is complex. So type C1 C1 is a complex data type. C1 is a variable with complex data type because the number stored in C1 is a complex number.
Oh.
So mind complex number. Complex number, let us take the sum of two complex numbers. Let us take the sum of two complex numbers. So the C1 equals 2.3 plus 3.4j. So the equals C1 money equal means you assign the number on the right hand side to the variable in the left hand side. Equal have assigned to. So 2.3 plus 3.4j have a complex number C1 the hape assigned to. Then minus 3.1 plus 1.2j have a complex numbers this is assigned to the variable C2. Then C3 equals C1 plus C2. How do you know? You take the two complex numbers C1 and C2, you take their sum, and then their sum is that the value of the sum is assigned to the variable C3. Now we print sum equals C3. So let me run this program. Let me run this cell. So sum equals this 2.3 plus minus 3.1. It should be minus 0.8. 2.3 minus 3.1 is minus 0.8. But what is the actual number you get here? The actual number you get here is 0.80000000003. The 3 you got. This 3 is an error. 3 is error. Yeah. And what is the error? It is a very small error. And this has to do with how floating point numbers are stored in computers. Computer da floating point numbers stored to ge habido. Adugi matung in anish data yam pick error 0.000000003 I'll share a video with you explaining how floating point numbers are stored in computers. Floating point numbers computer stored to these are stored as approximate values, not as exact values. Zoom recording. Here we get this error 0.00003 because of the way floating point numbers are stored in computers. Floating point numbers when they are stored in computers, they are not stored as exact numbers, they are stored as approximate values. Approximation to the small error. So ideally we should get minus 0.8 plus 4.6j. 4.6j. Sigi Anis the D Chapsa Velu Pange, but Sizadi Chapsa Velu the Pandre. Kashukai ko. Next Lasi. Next you are familiar with binary numbers, hexadecimal numbers, and octal numbers. Let me run this cell. Today, this, and this. Binary numbers. Binary numbers have the kind of binary numbers have the 0 go 1 go the same number to binary number. Decimal number hai na kind of decimal number hai na mangon the yawo but digits there are 10 different digits. 0 dagina 9 hoba 0 1 2 3 4 5 6 7 8 9. Aduna sigi digit tara jina same number duguna decimal number kaure. Only 2 digits 0 and 1 same number duguna binary number kaure. Hexadecimal number haigana we have 16 digits. 16 digit na same number dugu hexadecimal number kaure. 16 digits include kari no 0 1 2 3 4 5 6 7 8 9 9 gi mathang dagi A B C D E F. These are hexadecimal numbers. Aduna saida A yaurise ko A yaurise. This is also a digit makhalama neba. The octal number havna kano octal number havna 8 na base over number 8 na base over 8 na base over have the numbers formed by 8 different digits. 8 different digits dagi khangalaga same numbers into haidi kano 0 1 2 3 4 5 6 7 0 dagina 7 bhavuna same yaba numbers into these are octal numbers. So binary number gina magi base kaino 2 ni hexadecimal number gina magi base kaino it is 16. Octal number gina my base kaino base 8. So say the output on a print or agency last numbers in manage to print to. So let us print this second numbers print by this binary number. So the hash binary number hash signs whatever comes after the hash sign, it is a command. Command lines execute only this number will be executed. Whatever is written after the hash sign, it will be neglected because it is a command. Command never go. So let me copy this. Say copy to sorry. Copy to see hana select Control C namo aduga mono co-laptop run Google co-laptop. Google co-laptop plus add aduga let me paste here Control V and let me run it here. Run 105. This is the decimal equivalent of the binary number 1101001. See binary number ne has man Python how does Python know that this is a binary number? Because it starts with 0 small b. 0 lowercase b however. 0 lowercase b however it means it is a binary number. Here I go. So the say the 0x it is a hexadecimal number. So let me copy this and run it again on Google Colab. Control V paste so 0x this means it is a hexadecimal number, and let us find out the decimal equivalent of A210. Let us run this by clicking Shift Enter. Shift Enter name output 41488 name. There you go. Next octal number. Octal number is 286 the Control C and Control V. Control V is the best. Let me let me press Shift button and Enter button on my keyboard. So this is the output is 286. 286 output pangeko. So this is the output which we obtained here. There you go. So this is all these numbers. Binary, hexadecimal, octal numbers. I will say Python handle the Python can handle binary numbers, hexadecimal numbers, octal numbers. There you go. Sigi 100 numbers in repeat the button. So 105 target. 105 target. Next, x equals 38.99. X equals 38.99. Have you guys now? So that 38.99. Hariba floating point numbers. The decimal the floating point number. So 38.99. Hariba floating point numbers. This is assigned to the variable x. This is assigned to the variable x. What will be the data type of x? X ki data type kari orani. Floating point number. So when so let me run this on Google Colab first. So 38.99. So I put x equal to 38.99. 38.99. Let me press Shift Enter. There we go. So let us print. Not some type. Type. I did it. Type x. So what will be the output? This will give us the data type of x. So let me run this by pressing Shift Enter. Float. So make x equal to 38.99. Have 38.99. How floating point number z x have variables the assigned to. So that means the variable x is a floating point number. Magi data type c floating point data type never. The floating point data type a integer to convert to type conversion. So this is what I'm doing, type conversion. Floating point number I'm load. Floating point number is the int function int function x operate. So int x, what will be the output? This will produce the integer part of the number. 38.99 integer part. Let us run this and you will see 38. So sigi x hariba x hariba sigi x hari say it was originally a floating point data type. Now int x harigadi, the type has been converted to integer type, and x ki value kari 38 38 the remaining decimal part is neglected. Smine y have a variable amount low, then 35 have integer z y is the assigned to y have a variable amount, you assign the integer 35 to the variable y. Y data type y is integer type. Now float y this float y hariba sigi statements this will convert y to a floating point data type. 35 hariba y the yariba number z floating point data type on y say the number floating point on yarani. So how is 35 converted to a floating point number? Let us see. Let us run this cell. 35.0. So integer floating point type to on 0.0 the floating point integer on the decimal part is ignored. We can also create a complex number by giving the real part and the imaginary part. Complex 3,6 haragadi sigisi 3 plus 6j. The first argument is the real part, the second argument is the imaginary part. So let us run this and see the output. So 3 plus 6j. And complex number I'm going to define to define to next the Boolean data type. This will be the last topic for today. Boolean data type. The Boolean data type represents Boolean values. There are only two Boolean values which are true and false. Python internally represents true as 1 and false as 0. I digital electronics ta karitam kare. Digital electronics ta Boolean data type haiba kumatam kare ko true and false haiba ma. So Boolean data types say the value ani kaktang lay value ani judi amana true ni amana false ni. So x equal to false harigadi. So say you should you should be careful that Boolean value false. It starts with a capital F. The Boolean value false, it starts with a capital F. Small f na take off. So false hariba Boolean value z aina x hariba variable is hapsale, and then I print the data type of x. I should get a Boolean as the answer. Bool, B-double-O-L, bool thole ek of Boolean data type. Print x, see, let us print it. It prints the Boolean data type which is stored, the Boolean value which is stored in the variable x. X is stored to the value to never false, never mana print is. So in Boolean data types there are only two values, true and false. Both starts with capital letter. So let me end here for today.